Hello, my dear students. Myself Anupam Panchal. I am welcoming you in your physics class, and today we will talk about some very interesting concept of rotational motion. One numerical, very interesting numerical. What we are doing? We are throwing a ball, a solid sphere, at the corner of a wall. Okay, this is vertical wall. This is a vertical wall having a corner like that, horizontal surface and vertical surface. And if we are, what we can say, we are putting a ball which is rotating with angular velocity omega naught, initial angular velocity omega naught, having radius r and mass m. What will happen? Since these two surfaces are rough surface, so these two surfaces will apply retarding torque. After some time this ball will stop, okay, stop rotating. So one friction force F1, which is horizontal backward direction, and one friction force F2, which is vertical upward direction at these 2 points of contact, at these 2 points, point number 1 and point number 2. Okay. And due to this friction force, due to this F1 and F2, this ball will stop after some time, after some number of rotation. So what we have to find? First we have to find the angular acceleration. Find angular, it is not angular acceleration, it is angular retardation. Angular retardation of ball. Okay, what should be the moment of inertia of a spherical ball? It is 2 by 5 mr square. Okay, and B, we have to find the normal reaction. Since these two surfaces, ball surface and horizontal surface, are in contact, so this horizontal surface will apply normal reaction N1, normal reaction N1, and this vertical wall will apply normal reaction N2 on the ball. So find the normal reaction, find the normal reaction on ball by the walls. Okay, and third part, we have to find the number of rotation before it stops. Okay, so find number of rotation before it stops. Okay, so these 3 questions we have to solve in this video. Okay, so if this ball is not performing any kind of translatory motion, center of mass is in rest, so we can apply FBD, we can use FBD for equilibrium. So mg, which is vertically downward, weight of this ball, normal reaction N1, which is vertically upward, and normal reaction N2, which is horizontal forward direction. Okay, this F1, which is in backward direction, and this F2, so we can add this F2 with N1, which is vertically upward. So what we can write? We can write mg should be equal to N1 plus F2, and N2 should be equal to F1. Okay, now this F1 can written as mu times friction coefficient, kinetic friction coefficient mu times N1, and this F2 can written as mu times N2. Now we are putting value of F1, so N2 is equal to, what is F1? F1 is mu times N1. Okay, and what is N1? F2 is mu times N2. Okay, so mg is equal to N1 into plus mu times N2. Now I am putting value of this N2 in this equation. Okay, so mg is equal to N1 plus mu times N1. So from here we are finding N1 is equal to mg divided by 1 plus mu square. Okay, this is the normal reaction N1. Same as it is, we can find N2. What is N2? N2 is mu times N1. Okay, so we can find N2. I am writing here N2 is equal to mu into mg divided by 1 plus mu square. This is the N2. Okay, so the second part is completed. We have find normal reaction N2 and normal reaction N1. Okay, N2 and N1. Now this angular acceleration of ball, angular acceleration, to find the angular acceleration, this F1 and F2 both are providing retarding torque which is equal to I into alpha. So this F1 is equal to mu 1 into N1 and F2 is equal to mu 2 into N2 into radius r, which is equal to 2 by 5 mr square into alpha. From this equation we will find alpha. What is N1? What is N1? It is not mu 1, it is only mu. So mu into N1, what is N1? It is mg divided by 1 plus mu square. It is mg divided by 1 plus mu square plus mu into mg. What is N2? N2 is mu into mg divided by 1 plus mu square. It is into r is equal to 2 by 5 mr square into alpha. So m and r will cancel out. This m will cancel out and r also cancel out. So finally we are getting alpha is equal to 5 by 2. Okay, 5 by 2 r. 5 by 2 r. Here we are getting mu divided by 1 plus mu square plus mu square divided by 1 plus mu square into g. So finally alpha is equal to 5 by 2 r into g, mu plus 1, mu plus 1 mu we can take common. So mu g 1 plus mu divided by 1 plus mu square. This is the angular acceleration. Okay. Now to find number of rotation. So when ball is stopped, its omega will be 0. Its omega will be equal to 0. So we can use omega square is equal to omega naught square plus 2 alpha theta. Okay. This omega is equal to 0, omega naught square given and minus 2. This alpha is retarding. So I am taking negative. Minus 2 into alpha theta. So from here we can find theta, which is equal to omega naught square divided by 2 alpha. This theta can written as 2 pi, total number of rotation n, is equal to omega naught square divided by 2 alpha. So this n is equal to omega naught square divided by 4 pi alpha. Now we can put this alpha, in this n. So we can find the number of rotation before it stops. Okay, very interesting numerical is there. Okay.